Hello there. So recently I decided to learn Go language, and in this video I just want to share my approach to learning a new language. It won't work probably if you are a beginner in software development and Go is your first language. I'll mostly focus on experienced developers. If you're familiar with common approaches in software and you know one or two languages, something like Java or something commonly used, I think this is a nice way to quickly understand a lot about the language, about the ecosystem, and to gain some hands-on experience as well. So all that I'm going to talk about are written in my blog as well. So if you prefer a text version, the link will be in the description. So my approach is not wasting too much time, not trying to get all this structured knowledge. Don't read any books as you're just starting. The main goal is to write your first code as fast as possible and then create a workflow so you can iterate and try new things really fast. So in Go, it's really easy because the project setup is really simple. You just install Go and then you create a folder and run Go mod init inside, and basically you're good to go from that. You can import additional libraries, you can run and execute your main function, and after that you probably can just play with the main function for a while, put some code there, try some things, but eventually the main function could be tricky to use because you always need to change things inside. So what I suggest you becoming really comfortable with is writing some simple tests, and let's take a look how you can do that. So for example, we create a new function. Let me delete this. So let's say we want some simple function in Go. We do something like func, and let's call it some numbers, right? And then we have an int and then an int as well. We want to return an int, return, and we just do some of that, right? So instead of calling this function from main, you probably want to create a _test file, and then you basically have access here to test what you want. But first, before we start, that's the first finding that I made in Go is that the built-in test assertions basically non-exist. So as I got it, but there is a function library called testify, a package that we're going to use, and you can do it by calling assert, and you now have access to things like equal, and then we put t here. Let me delete everything like this, and here basically you have an expected value, let's say 5, and then we can call our function here. So let's do something 3 and 3, and to validate we can run test, which should fail now, right? Yeah, so now we have a failing test, and we now have an easy way to iterate and try new things. So that's the main point number one. Set up your editor, set up the testing, the unit test, so you can quickly validate that functions that you're writing are doing what you expect. Cool. But after doing this basic setup, I suggest we dive straight into developing a service, right? And these areas are most commonly used in any language if you're doing some sort of backend development, building microservices or whatever. And those areas are basically how you create a web server, how you create routes, what libraries are popular and useful in this area for the for the router or some kind of web frameworks. You need to investigate what's popular in the language, in the ecosystem. Once you've done that, the other part is how to work with JSON, because basically JSON is the main format nowadays for the HTTP requests. Of course, if you're not doing the gRPC approach. But yeah, I'm usually really interested how you work with JSON in language, just to understand how you serialize, deserialize data, etc. And also in this area, you will learn how you model your data, right? So in Go, we have structs, and in other languages like classes, etc. Cool, so JSON, and then you combine these two, so you now have an API that returns a JSON format. And after that, the final bit is to add persistence layer. So we want to introduce some kind of relational database. And I highly suggest starting with SQL relational database, because it's, from my experience, still the most popular option. And if you understand how that works, you'll cover most of the cases. And if you need non-relational database, NoSQL, you can do that later. So let's start with the web server. I made a bit of research, and there are a couple libraries available. Yeah, so we have Gin, Echo, Fiber, Chi, Gorilla, but I wasn't looking for, like a big framework. I wanted, and also coming from Clojure background, I just prefer lightweight libraries for things. And after some research, I think Chi is kind of popular option, and it's also really lightweight because it's literally just a router with option to register middleware on separate sets of routes. So I picked this one, but before that, you can probably just start creating a web server with only built-in like core language packages, and there is like a net HTTP, and with net HTTP you can literally create a web server with like a couple lines like this. So basically you register your handler and then the root, and you can configure your application to listen on specific port. But let's jump straight into Chi, and this is their main example how to get started. And we can see here we're creating a new router, then we register the login middleware, and basically after that we able to create new routes as we go. So we have like a just slash here, but you can add more routes as you go. So just a couple lines, and after that you can just run your main function with go run dot, and you'll have a working web server, right? So let's go here. I have a bit more code already, but really the main here is this. In the main function, we're just creating a new router and register some routes here. Cool. After that, we have JSON, as I said, and here we have two options. So one is standard package called encoding JSON, and with that you can convert your structs into and serialize them into JSON. Let's try that. So I created like a user struct which has ID and name, and for JSON we can use these tags that basically will tell that when we serialize it to JSON, this capital case ID will be converted into lowercase ID, and name started with a capital letter will be converted to a name all lowercase. But you can do whatever you want. You can do like a first underscore name here. This will all work, but let's keep it name. And here we have our test function, really handy, because now we can do something like user, and let's say it will be user, and we create it with ID 1 and name, let's say Andre, And after that, we want to use json.marshal, and then we pass the user inside. So result of that will be a byte array. So a byte array, so let's say user bytes, or it could be an error, which we can ignore for now. And after that, let's create an assertion. So we want to assert equals. And here we have test. And then we will do something that expected. And here we just convert our byte rate into a string and pass our user bytes inside. All right, let's run our test. So go test, it should fail. And we see that we're expecting this string, and we can do it here. So let's do /id. It will be 1, and then name should be Andre. Let's run that again. And now we're back to passing test. So here how you convert a struct to JSON. But as we picked Chi as the library, there is a render package from Chi as well. And we can use that to help us with correct headers in the responses, etc. So it works like this. So basically we have here a get user JSON endpoint, and I'm creating the user and initializing the struct, and then we call the render and we pass status and the render. And this will work only if you extend your struct and add a function that implements this render function. So once you've done that, you can literally just call it like this, and it will be correctly rendered into a JSON. So let's go here and let's rename. So as you can see here, we're defining some URLs, some roots, and /user will be calling this get user JSON endpoint. We can now run our application. So let's go to /user, hit enter, and you see we have our correct response. So the next big one, as I said, is working with SQL. And I don't really like ORMs, probably due to my early days in software development when I had to work with Java and Hibernate. But basically, seriously, ORMs have its own niche, I think. But my problem is that sometimes when you start building something, your application is too simple to use ORM. But after it grows, usually there is a point when your application becomes too complex for an ORM. So it's not perfectly matching what ORM provides. And in that case, you try to work around the ORMs, you try to optimize the queries that are generated that you cannot fully control. So I prefer a simpler approach, just work with a database and write plain queries. The thing that I enjoy is some kind of query builder, and it depends on the language. So when I was working with Java, I was trying to move from Hibernate to a library called Juke, which was a library that allowed you to write type-safe SQL queries. And it worked like you use the generator from the library that was going into your schema in your database, and it was generating Java classes based on that schema. And after that, you have all auto-completion inside your queries. And here I was looking for the similar option, and I found like almost exactly the same approach. And the library is called Jet in the GitHub Go Jet right here. And they provide an example for the schema. So here we have a file which is like a creation of the database, and then it will be like filling the data for us. So I use that as an example, and inside our application I was running something like jet and then this command. So basically we're defining a schema and path that will be the path of the output and then our local database. Once you run that, you'll have a new folder .gen with the database models and Go files right here. So it's really simple. The main one is like model, I think, and if you go to film, for example, you see that our table structure is defined as a struct in Golang. So what we can do after that, basically we can write our statements like this. So you have like select from the library, and then from, you use the film table, then we can create some expressions like where film length is greater than this value and order by, etc. And basically it provides an auto completion for you. So for example, instead of all columns, let's see what's available. So let's say description, and now in our query we just select the description right here. Let's actually change it to all columns. So that's how you build a query. After you created the query, we want to execute it. But basically, it's just like this. So we have our output struct where we want to put the result. We just want a model film there. This is the destination, and then we do query on our database object, and it will fill these films as a result. And yeah, it's a bit of junk here, but at the end we're still using this render, and we rendering the film response struct with a film inside, just a single one, and we return that. So let's actually change it to, let's call it just like a film. It's not really a REST API, but yeah, it should work for now. Let's restart the server and let's try this /film endpoint. We were calling user, but now let's try /film. And here we have some response from the backend, and it's actually one of the films from the database. One other thing I wanted to discuss is, and that's one of the areas I usually interested, is how you pass your dependencies inside your code, inside handlers, because usually you want access to at least the database connection, database handler. And here I was following the most simple approach, basically just put it as a global var. And for simple application that works. For more complex things, when you have more dependencies, that won't work. But what I want to share is a really nice article right here about organizing database access in Go. And it basically starts from the easy one with a global var, but then we have things like dependency injections here and the closures, closures, and also there's a way to pass it as a context in the handlers, but it's not really recommended, as I understand, in the request context, because it should be just things related to the request. So if you're interested, there's a really nice article. Again, you can find the link here in my blog post if you want. And yeah, finally, I looked into making HTTP requests, and I created a new handler with a proxy, and inside the proxy I'm just calling some random API available on the internet and checking how it's working in language, how you do outgoing HTTP requests. And right at the end, I just want to mention that I wasn't running my local database as a Docker, and I basically it was running it in a Docker container. I wasn't just manually starting it, because in most cases I just prefer to use test containers, and it basically allows you to control your Docker images from your application code. And usually it's used in tests by the name of test containers. It's basically for the tests. But here I just used it in a hacky way, and I just used this code inside main function before I running the web server to start the database. And when I run main, it basically goes and talks to Docker agent, and it spins the container that I need. And here I'm just providing the names, DB name, username, and here I'm putting this init script, which I took from Jet, and you basically just put it here, and on the start it will apply this initial migration. So once the database is running, you have all the tables inside and all the data, which is really handy for quick local development and trying things. So yeah, highly recommend test containers. Go is supported as one of the languages, and a lot of containers are supported as well. So it's really cool. If you're on database, if you're on Kafka, Redis, whatever you're interested to try, it's probably the most easy way to get started. Cool. So hope you enjoyed my brief introduction, and I'm planning to learn Go more seriously probably. So expect more videos on the channel. If you're interested in that, please subscribe. And also it really helps when you comment and like the video, so that really helps. All the links will be in the description, so check it out, and see you next video. Bye bye.